Hello students, welcome to the IIT PAL series on statistics. My name is Vetrivel, I am a professor of mathematics at IIT Madras. This is a continuation of the lectures on statistics delivered by Dr. Nilesh Upadhyay, and let us start with one important notion called the measure of variability, also known as coefficient of variation. In this lecture, we introduce a notion called coefficient of variation. And you have learnt that an observation xi in a given data, when it is having certain units, then x bar, the mean and the standard deviation all have the same units, right. We have seen already that. And now I define the coefficient of variation, which we in short will let us write it by CV. The CV is defined by, with respect to the x bar, that is sigma of the any given data, that is standard deviation, divided by the x bar multiplied by 100 times. And this now if you look at this quantity in the right side, this is a dimensionless quantity, that is it is independent of the units now. So, where this is useful, that is, let us see now. And for instance, and we assume that of course the x bar is not equal to 0. Okay. For any given data, one can compute this measure of, this is the measure of variability. How the entries are varying, that is what it is measuring. For instance, suppose we have this is very useful when we generally when we want to compare the two given data sets. For example, let us say we have some data 1, okay, let me call data 1, and we have a data 2, and for that I assume that I compute this mean x bar, and here let me call it x1 bar, here let me call the x2 bar the mean, and the standard deviation let me call it sigma 1, and here it is sigma 2. And once we have, now I can compute the CV, I call it CV1, which is equal to sigma 1 by x1 bar into 100. Similarly, here also I can compute the CV2, which is equal to sigma 2 divided by x2 bar into 100. Okay. And now this is a dimensionless quantity. Now I can compare the CV1 and the CV2. In case the CV1, if the CV1 is bigger than the CV2, okay, CV1 is bigger than the CV2, we say that this first data set, this data set has more variability. If CV1 is greater than the CV2, we say the data 1 is more dispersed than the data 2, then the data set, then the data 2. So, that is the conclusion we can make when we compute the CV1 and the CV2. Also it is equivalent to saying that the CV2 is more consistent with than the first one. Equivalently we can say, also we can say this data 2 is more consistent than the data 1. So, this is the conclusion we can make. In case, for instance, if x1 bar is equal to x2 bar, then we can make this conclusion just with the sigma 1 and sigma 2. In case x1 bar is equal to x2 bar, in addition, then we can say if sigma 1 is greater than sigma 2, then that will automatically imply this conclusion. Okay. Then we can say data 1 is more dispersed than the data 2, or we can say data 2 is more consistent than the data 1. Okay. For instance, let us take a simple example to illustrate this. Let us suppose we have a record of heights and weights of students in a classroom. Suppose we have a record of heights and weights. of students in a class. Okay. Let us say if there are 50 students in the class, and now we can compute, we assume that the mean of the mean height, that is, let me call it xh bar, the mean height is equal to some quantity, let some number, let us say in centimeter, let us say 162.6 centimeter, and similarly I have this x in weights, the mean of the weights, mean weight is let us say 52 point some 36 kg, and now I also we assume that the standard deviation for the height is equal to some 11.3 centimeter, and here the weight, for the weight also we have the standard deviation, let us say sigma w, which is equal to let us say 4.81 kg. Now if I compute this CV, the coefficient of variation for the heights, now this becomes a dimensionless, because 11.3 divided by 162.6 and multiplied by 100, this gives 6.95, whereas here the CV, the coefficient of variation for the weights, it is equal to 4.81 divided by 52.36 into 100, that gives number 9.18. So obviously here the CVW is bigger than the CVH, and hence we say that CVW is bigger than CVH, and hence the conclusion is the weights show more variability. Okay. The weights show more variability, that is the conclusion we can make out of this given data. Okay. And let us see, if time permits, let us come back to this on this coefficient of variation for more problems. And before we do that, let us now start with the overall what in statistics, let us see some problems. The problem number 1. So consider the following data. Okay. This data is something like this. I have there is a factory and there are a lot of employees. Let us say there are 212 employees are there in a factory, and everybody is entering in the morning in the factory, and now there is a record of the late entries. Okay. So the minutes late, how many minutes are late for each employee. So let me call it this xi, and frequency, how many employees, so for example 0 minutes late. So people who are punctual, the frequency, the number of people, frequency, let me call it fi, and there are 181 employees on time, and 1 minute late, 2 minutes late, 3 minutes late, 4, 5, 6, 7, 8. So this is the data I have, and correspondingly we have this number of employees. 1 minute late, number of employees 13, 6, 4, 3, 2, 1, 1 and 1. So totally if you count it is 212 employees. Now for this data, now you see this, look at this data, data is totally extreme. There is an extreme number called 181, therefore you will see, you can compare with the mean and the median in this case. For example, now the question is this: find the mean, standard deviation, and median, and finally let us also compute the mean deviation. You have studied in one of the earlier lectures the mean deviation about the median. Okay. Let us analyze this given data, and we know that x bar, to compute the x bar we need we have the formula sigma fi xi divided by the sigma fi. The sigma fi is already known, it is 212. Okay. Now, and the sigma formula, the standard deviation is square root of sigma fi xi square divided by sigma fi minus x bar square. Now, let us, so we need to compute all these term sigma fi xi and sigma fi xi square, and then we substitute in this and get the values. And now, for that let us compute the next column called the fi xi. So, obviously this is 0, 13, 12, 12, 12, 10, 6, 7 and 8, and here the total is 80, and we also need fi xi square, and it is 0, 13, 24, 36, 48, 50, 36, 49, 64. Now, here the total is 320, and then now we can substitute, since we know the totals, then we can substitute, and the median. Now, what is the median here in this case? Now, I can, let us compute one by one. X bar turns out to be simply 80, the mean. X bar is sigma fi xi, that is 80 divided by 212, which is equal to 0.377. And the second one, the standard deviation, we have all the data sigma, that is sigma is equal to the square root of fi xi square, that the first term in the numerator 320 by 212 minus the x bar square, which is square of this numbers 7, and which is equal to square root of 1.367, which turns out to be 1.169. Okay. So, we can compute this mean and sigma just from the formula straight away. And then now, if you look at this median, now if you look at the median here, there are totally 212 employees here, and the median is the middle of the data, which is equal to somewhere 100, and the median is the average of the 105th, 106th and 107th. So, the third one is the median. Median is equal to the average of 106th and 107th entry observation, okay, which is equal to the xi values are 0 for that. Okay. So, we have, for because this is this data is something, it is a one entry is very big here. Okay. The value, the observation for that is 0. So, therefore, automatically the average is each entry is 0, and hence the median is equal to 0. Okay. Therefore, now we want to calculate the fourth one, that is the mean deviation about the median, okay, about the median, which is equal to mean deviation about the point 0, okay, which is same as, by formula we know that it is the difference, okay, the 1 by sigma fi, and the sum of all the deviations from the 0, that is xi minus fi xi minus 0. minus 0, which is equal to the same, it is same as the x bar, okay. And in this case it is the same what we have calculated in the previously, that is 0.377. So, in this given this sample, this data what we have, the median and mean deviation about the median give a correct picture of the sample, whereas the mean and standard deviation what we have calculated, that they are not, they are totally distorted by the extremely high value called 181, okay. So, therefore, all the 181 entries, the observation is 0. So, therefore, the correct picture is given by this mean and this median and the mean deviation about the median, okay. So, that is the conclusion we can make from this given data. And then let us go to the next example. Here we have a grouped data, okay. So, I have a students marks, let us take the marks of the students in a classroom in a particular test. Let us take this data. There is the range, the class, that is the students frequency from 48 marks to 54 marks and 54 marks to 60 marks, 60 to 66, 66 to 72, 72 to 78, 78 to 84 and 84 to 90 and finally 90 to 96. So, this is the class intervals given, and the number of students whose marks are in this class interval are given as this 2, 3, 5, 8, 10, 12, 10 and 1. Okay. So, this is the data we have. Now, let us for this group data, let us calculate the standard deviation, compute sigma for this given data. So, for that what we have to do is we have to calculate the midpoint of the class interval. We know that this is the lower limit and this is the upper limit. The difference is the midpoint is, for instance, in this case it is let us write midpoint and let us denote that by xi. So, it is 51, okay, and the midpoint of 54 and 60 is 57, 63, 69, 75, 81, 87 and 93. So, these are the values of the xi, and now we have what we need to compute the sigma I. We know the formula, again let me rewrite the formula. X bar we know, x bar, now if x bar is sigma fi xi divided by sigma fi, and sigma fi is the total. Let us the last row is for the totals, and here it is 51. There are 51 students in this class, and now let us calculate the fi xi. Fi xi will be 102, 2 into 51, 102, same 171, 315, 552, 750, 972, 870 and finally 93. Now, if I sum up all that, I get 3825. Okay. So, therefore, now I can immediately compute this the mean of the given data 3825 divided by 51, which is equal to 75. So, the mean is equal to 75. Now, we have now I am using this formula for standard deviation. We know that sigma square, the variance, is equal to sigma fi xi minus x bar whole square divided by sigma fi. Okay. And then to find the standard deviation, I can take the square root of that. Now, what we need is xi minus x bar, and then I have to sum it up with the, and then I take the multiply it with the fi. So, let us compute the xi minus x bar here. The deviation from the, so xi minus x bar will have both the negative and positive values. So, minus 24, so x bar is 75, remember. So, therefore, xi minus the x bar, okay, and minus 24 minus 18 minus 12 minus 6 0 6 12 and 18. And now, what we need is we have to take the square of this xi minus x bar square. So, xi minus x bar square. So, I need this also. So, then I can take the total of that. So, which is equal to 576. I am squaring these numbers, and 324, 144, 36, 0, 36, 144 and 324. The total before that, and now I have to, the final one, I have to multiply that with the fi. So, fi into xi minus x bar square. Okay. So, the last term. So, this is what we are going to use in the formula. So, the entries will be, that is, I am multiplying this 576 with the fi. Okay. So, that will be 1152, 972, 720, 288, 0, 432, 1440, and finally this 324. Now, if I sum up all that, so I get 5328. Okay. So, now I can substitute these values here. So, is equal to, the numerator is 5328 and denominator already we know it is 51, the value is 104.47. So, this is how we, for this grouped data, we compute the variance, and now I can find this by taking the square root of positive square root of this variance, we get the standard deviation, which is in this case it is 10.22. Next, we take one large sample. Look at these entries. They are, let us assume that they are marks of 50 students. Okay. So, 50 entries are there. Now, for this data, this is an ungrouped data. Okay. And for this the sigma square, I want to compute the variance. So, compute the variance. This is the compute the variance sigma square. Okay. And one way straight away I can apply the formula, that is the formula says you sum up all that. So, I am not going to sum up all that. So, the formula is sigma square is equal to the total number of entries is 50. So, 1 by I am just applying the formula 1 by n, 1 by n sigma xi square minus sigma xi whole square divided by n. So, this is, we know that this is the formula for the variance, and we have to compute, we have to take the square of each entry and then we have to do all that. So, let me not waste time on that, simply let me write down the values. So, 1 by 50. So, sigma xi square is a big number. So, 2,98,168 minus 3796 square divided by 50. So, this finally will turn out to be a big number called 199.52, and hence the standard deviation, if I want to compute it, can say it is 14.125. So, this is the standard deviation, okay, for this big data. Now, instead of that, we can now, the better way is we can group this data. Okay. How do we group the data? Now, we have the options. For example, in this case, what happens is, if you look at this data, it is starting from the lowest entry. If you see, the smallest one is 44 and the largest entry is 98. So, the difference, if you look at it, is 98 minus 44, it is 54. So, now I can group the, so in this case we can group the data like this. So, the 54, so 54 is the gap, okay, 98 minus 44, which is equal to 54. So, now we can group like this. So, we have the flexibility of grouping the data. So, we can group. Okay. As such, the problem is over, but what we are doing is, by grouping, we are going to compute the same variance by grouping the data. So, we can group or classify as follows. What I can do is, we can form 11 classes. Okay. Either I can form 11 classes of with 5 units, or I can also do 14 classes of with 4 units, or I can form 8 classes of with the 7 units. So, it is all up to us, and let us now form, let us choose the first one, let us form the 11 classes of with 5 units. Let us take the class interval. So, now let us form the table for the given data. So, for the given data I am just forming, you can trust me, the data what I am entering is correct. Class interval, and for the class interval, let me write, that is from the lowest is 44, therefore, let me put 43.5 to 48.5. So, 5 is the width of the class interval, and then the next class interval will be 48.5 to 53.5, and then 53.5 to 58.5, 58.5 to 63.5, 63.5 to 68.5, and so on. Seventy-three point five, 73.5 to 78.5, 78.5 to 83.5, 83.5 to 88.5, and 88.5 to 93.5, and the last interval is 93.5 to 98.5. Now, for this these class intervals, I can choose the midpoint, that is our xi, which is simply 46, the midpoint of this is 46, 51, 56, 61, 66, 71, 76, 81, 86, 91 and 96. Okay, so these are the xi values, and the correspondingly now from the given table, the initial table, we have to compute how many what are the entries lying in this interval 43.5 to 48.5, that frequency we can calculate. So, let me put Fi here, and you can trust me, it is 4, 1, 2, 2, 2, 9, 5, 10, 4, 8, 3. Okay. And the totally, as I said, there are 50 students, therefore, this number is 50. So, these are the totals, and now, so what we need for sigma square is, let me write this formula, sigma square, the variance is equal to 1 by n sigma Fi xi square minus sigma Fi xi whole square divided by n. So, this is the formula for the variance. So, what we need is Fi xi we have found. So, we need Fi xi and Fi xi square, all that we need. So, let me calculate the xi square and then let me calculate the xi Fi, and finally, I will calculate the xi square Fi. So, these are the things we need to substitute in the formula. So, xi square, the square of 46 will be 2116, 2601, 3136, 3721, 4356, 5041 and 5776 and 6561, 7396, 8281, 9216. And now I calculate the xi Fi, and xi Fi 184, 51, 112, 122, 132, 639, 380, 810, 344, 728 and 288. Now, I am not going to write the last entry, which will be a bigger number. So, let me write down the sum. So, sum is 2 lakh. So, this sum is 3790, because we need sigma xi Fi, Fi xi sum we need, and Fi xi square sum we need. So, we need this total. This total will be 2,96,830. Okay. So, that is all. Now, if I substitute all this, I can find out the values. So, 1 by 50 times the number 2,96830 minus this 3790 square divided by 50. This gives the variance 194.96, and finally, the sigma value will be 13.82. Okay. And whereas by the ungrouped method, if I compute this variance, it is sigma is 14.125. Now, here it is 13.82. So, the naturally the difference will appear, because each value in the given data is taken as the midpoint here. Okay. We are approximating as a mixed point for each data entry. Now, it is approximated as a midpoint. Therefore, definitely there will be a difference in the final value. So, that is what we have seen in this example. And next let us move on to the next important example you have studied in the previous last lecture of the Dr. Nilay Supatyay, that is by approximating the, when we want to calculate the standard deviation or the variance, we approximate the mean. Instead of computing the mean, we give some approximate value what is called the assumed mean, and then we can compute the variance. Okay. So, let us let me take the data, some data, let us say xi is 38, suppose 38, 70, and this is a ungrouped data 38, 70, 48, 34, 42, 55, 63, 46, 54 and 44. Okay, so, these are the data I have, observations, and now I am going to use the let us choose now I want to calculate finally this sigma square. For that I am just going to apply an approximate value for the mean. So, what I am doing is I am going to calculate the di. Okay, so, the di, so for this case let us choose the mean to be B50. Now, if you look at this data, either you can choose any number between 48 and 52, you can choose choose that as a mean. So, let me choose a convenient number 50, and here remember that n is equal to 10. Okay. So, now I have to calculate this deviation di is equal to the difference xi minus a. Okay, the a is our x bar. Okay, a is our, so this is our a is equal to 50. So, now I am calculating the deviation, which will be minus 12, because the number is now reduced to a small number. So, easy to handle, minus 12, 20, minus 2, minus 16, minus 8, 5, 13, minus 4, 4 and minus 6. Okay. Now, the formula we know that it is, you have seen in the previous lecture, the variance sigma square is equal to 1 by n sigma di square minus sigma di divided by n whole square. Okay. So, what I need is sigma di and the sigma di square. So, now it is easy, now squaring that will be a smaller number, will be easier always. So, di square, if I substitute all the values, di square 144, 400 and so on, 4, 256, 64, 25, 169, 16, 16 and 36. Now, this sum, if I calculate the sigma di, it is equal to minus 6, whereas here this 1130. Okay, now directly I can substitute in the given formula. I get 1 by 10, 1130 minus 36 divided by 10. So, if I simplify, the value is the variance will be 112.64 and the standard deviation will be square root of that, which is 10.61. Okay, now, let us see some miscellaneous problems on the variance and mean. For example, let us take miscellaneous examples. So, here let us take 20 observations. And it is assumed that variance is 5. Now, each observation is multiplied by some number, some constant, by a constant, let us say here it is 2 here. Then what will be the effect in the variance? That is what we want to see here. So, what will be the change in the variance? Certainly, even one observation is multiplied by, each observation here is multiplied by 2. So, everything now will be shifted. Okay. So, we know the formula for sigma square. So, how to find the new variance? Find new variance. So, that is the problem we have. So, let us calculate the sigma square. We know it is equal to 1 by n sigma xi minus x bar square. Okay. And so, I have to calculate the x bar now. So, here x bar is variance, it is given 5, the number of entries is 20. So, therefore, this summation now will be equal to 5 into 20 100 xi minus x bar square. Okay. So, this is I equal to 1 to 20. So, the what information we have got from this is sigma I equal to 1 to 20 xi minus x bar square is equal to 100. So, let us call this equation 1. Now, let us look at the resulting observation. Now, each entry is multiplied by 2. So, each xi is multiplied by 2. So, let me call that new number as yi. Okay, that is xi is equal to yi by 2. Now, what happens in the mean? So, now let us compute the mean for these yi's, which I call y bar, which is equal to sigma of yi I equal to 1 to 20, same 1 to 20 observations, which is equal to 1 by 20. So, 1 by 20 sigma 2x, yi is 2xi, we know that I equal to 1 to 20, and finally it turns out to be 2 times the x bar. So, the y bar, the mean of yi's is the twice the mean of the xi's. So, therefore, x bar is equal to y bar divided by 2. So, this is the relation between the xi and yi and the x bar and the y bar. Now, I substitute in the given equation 1. Okay. So, the 1 becomes from 1 we write sigma I equal to 1 to 20 yi by 2 minus y bar by 2 whole square is equal to 100. So, this now I can take the 2 outside. So, it will become 1 by 4. So, 4 will go to the right side as 400. So, 1 by, so therefore, what we have is the new variance sigma square is equal to, so 1 by 20 sigma I equal to 1 to 20 yi minus y bar whole square is equal to 100 by 5, which is equal to 20. 20 is, now if you look at the 20, this is simply 2 square into the old variance 5. So, now the variance is the variance initially it was for the original data it was 5, now it is changed as 20, which is 4 times the old variance. The 4 is nothing but the multiplication, the constant, we are multiplying by the number 2. Okay. So, the case the 2 square times 5 it has become. So, therefore, we can generalize this result also, that is if I multiply by any constant k, the new variance will be k square times the old variance. So, that is one important point we have to observe from this. And also there is another important remark is, instead of multiplication if I add or subtract each observation. Okay. If you can prove this in fact, if instead each observation is added or subtracted by a positive number, let us say, then what will be the effect in the variance? Then the variance, if you look at, whereas in the case of multiplication we have seen it is really affecting the variance, but here in the case of addition and subtraction by a positive number, it will not affect the variance, the variance remains unchanged. The new variance also will be the same. So, this you can take it as an exercise and prove it. Okay. And finally, there is one more type of problem, just with that I want to finish. So, let us take mean and the second example, the mean and standard deviation. Let us take there are 100 observations, and let us say x bar is equal to 40 and the sigma is the standard deviation is 5.1. Suppose in that one observation, one of the observations, okay, one such observation is replaced. Let us say let me be specific, one such observation is let us say 50 and it is replaced by 40, that is it is discrete, that one observation is decreased by 10, it is replaced, the 50 is replaced by 40. Now what will be the new mean? Okay, what will be the, that is a question here. The new mean and standard deviation, the new standard deviation. So that is the question we have. So it is so what we do is now you have a x bar here. So there are 100 observations, therefore the sigma xi will be equal to, because x bar is equal to sigma xi by 100, therefore sigma xi equal to 1 to 100 will be 4000, therefore and the new sum definitely, since one term is 50 is replaced by 40, therefore the new sum, okay, new sum will be, the whole sum is 4000, the new sum will be 3990.
X bar is 40, not 400. X bar is 40.
Yeah. Sorry, x bar here in this problem is 40. Okay. And hence new mean (3990) by 100, which will be equal to 39.9. Okay. Similarly, I can calculate the variance, the old variance 5.1 square is equal to 1 by 100 sigma xi square minus this 4000 square divided by 100. This is the formula, we know that, and from this you can see that sigma xi square, from this you can calculate that sigma xi square will be equal to, I cross multiply all that, so it will turn out that 162601. So now the new, now this is the old sigma xi square, now new sigma xi square, remember one term is replaced, 50 is replaced and 40 is added, okay, therefore 162601 minus 50 square plus 40 square, okay. So therefore the new sigma xi square will be 161701, and with this we can calculate the new sigma square, okay. New sigma square will be equal to 1 by n, that is 161701 by 100 minus 39.9 square, okay. So which finally will turn out to be 25, you can verify, and hence the new standard deviation, new sigma, is equal to the positive square root of the 25. So the change we have seen in this problem, how one entry is replaced by another number. Okay. Finally, we shall see one more example where we shall find the mean and standard deviation for a group data involving, we will assume that the data represent the age distribution for a group of people, okay. So for example, let us consider the class and the distributions in the following pattern. The class starts with let us say 20 to 30, 30 to 40, 40 to 50 and so on with the corresponding frequency. So the 30 to 40, 40 to 50, 50 to 60, 60 to 70, 80 to 90, and the corresponding frequencies, let us say in the age group between 20 and 30 there are 3 people, okay, and in this age group 30 to 40 51 people, and here 122 people, and here again 141 and 30. I think I have done some mistake. So, it is between, it is from 70 to 80 and 80 to 90. The corresponding frequencies are 51 and 2. So, totally the total number of people is n equal to 500. So, now for this data, now we have to find the mean and standard deviation. So, we will see the distributions with large numbers. So, to let us find the mid values 25, 35, 55, 55, 65, 75, 85, and now we have to choose the mid value here. So, this is what the transformation we are giving. We will shall choose A is equal to 55, the mid value, and of course, here the class H is equal to 10, the length of the class interval. And now for this, now we let us compute the ui, which is defined as xi minus a divided by 10. Okay, here a is equal to 55 and h is equal to 10. So, it turns out to be minus 3, minus 2, minus 1, 0, 1 and 2, 3. And for this, let us compute this fi ui, turns out to be minus 9, minus 102 and minus 122, 0, 130, 102, 6, and the sum is easy to find, which is equal to 5 here. Next we shall find the ui square, which is equal to 9, 4, 1, 0, 1, 4, 9. Now, fi ui square, fi into ui square, which is equal to 27, 204, 122, 0, 130, 204, 18. So, the sum is equal to 705. Okay. Now, let us find the mean. We know the formula. The x bar is equal to the a plus the transformation what we have given, a plus h into 1 by n plus 1 by n into sigma fi ui. Now, if sigma square is equal to h square into 1 by n sigma fi ui square minus 1 by n sigma fi ui whole square. Okay. Now, we have computed all the values, we can substitute all the values here and find the values of this x bar and sigma square. Here in this case, x bar is equal to 55.1. So, that is the average, and sigma square will turn out to be, if we substitute all the values, we get 14099 divided by 100, which is equal to 11.8739. So, this is how we compute the mean and the standard deviation, and with this we are done. So, in this lecture we have started with a coefficient of variation, and we have how to compare the two given data we have seen, and also after we have seen some problems on how to compute the mean and median and mean deviation, about median, and for a group data how to deal with and ungrouped data how to deal with. All this we have seen. I am sure you have learned something through this lecture. Thank you for watching.